So, what do you think? Does a car speedometer measure speed, velocity, or is it both? What do you think? Well, for those of you who know the car parts, yes, Olivia, you have a question? You're still muted, Olivia. Unmute yourself. Huh? See, I'm sorry, I cannot hear you. All right. Well, the speedometer, okay, only measures the instantaneous speed, okay, nothing else. So, what's the matter here? Somebody's saying something. Oh, okay, yeah, yeah. The internet's not really that strong right now. All right. So here, um, all right, speedometer. Speedometer basically only measures it only measures the speed at that instant. Okay? It only tells you how fast you are going at that moment. That's what speedometer measures. To measure velocity, okay, one will need a speedometer and a compass to show the direction. Okay? To measure average speed, speedometer does not measure average speed. Okay? To measure average speed, one will need an odometer. Odometer is what measures the mileage that you drove. That's odometer. And a clock to get the time. All right? So the speedometer only measures the instantaneous speed at the moment. Number two, can an object have a varying velocity, okay, if its speed is constant? Well, let's understand what this varying velocity means. This varying velocity means velocity is changing, right? And there are only two ways you can change velocity, right? One is, right, velocity can be changed by changing its magnitude. That is, changing its speed. Okay. A second way of changing velocity, okay, by changing its direction. So you turn the car. Okay? So even if you're going at a constant speed, you can change velocity by just turning your car. Okay? So the answer is yes. Okay? Velocity can be changed by going constant speed by changing, right, direction, right, at constant speed, right? You can change velocity going at constant speed. An example of that will be driving in a circle at a constant speed. So when you're driving in a circle at a constant speed, you are changing velocity, moving at a constant speed. All right? All right. Number three. Number three. Can an object have a varying speed if the velocity is constant? Well, let's understand what it means by having a constant velocity. Constant velocity means the speed is not changing, right? So one, speed is not changing. Right? Two, the direction is also not changing. Okay? Well, if these two conditions have to hold, how could you vary your speed and have constant velocity? It's almost impossible. So, no, right? You cannot, right? When speed varies, velocity must vary. There's no negotiation about that, right? So when speed varies, right, then the velocity must change. There's no negotiation. All right. What about number four? When an object moves with constant velocity, Does its average velocity during any time interval differ from its instantaneous velocity at any instant? Well, let's think about that. Again, the constant velocity condition, you have to have two things. The speed has to be constant and the direction has to be constant, right? That means it has to be going in a straight line, right? At a constant speed. Therefore, any instant during that time interval, right, your velocity has to remain at that constant velocity, at that constant speed, going in the same direction. All right? So, will it differ? And the answer is no, because it has to maintain that speed and direction. All right? So, in order to maintain constant velocity, right, the instantaneous velocity during at any instant right, must be the same as the constant velocity. During that time interval. All right. All right. Number 5. In drag racing, you shouldn't be drag racing anyway, but anyway, let's say you're on a drag racing strip, which is legal, right? And you're drag racing your friend. Is it possible for a car with greatest speed crossing the finish line lose the race? I mean, what would you say? Is it possible? Anybody drag race here? No? I mean, I could give you an example, right? I could take out, I could take out my Porsche 911 Turbo. You know, everyone has one of these in the main line, right? So if we were to take out a Porsche 911 Turbo, right? And let's say I drag race, and I could actually drag race just in first gear. I don't even have to move into second gear. I can actually go from 0 to 60 miles per hour in first gear in 3.2 seconds. Okay? So I could drag race my Porsche 911 Turbo in first gear, right? 60 miles per hour, right? In 3.2 seconds. and then stay at that for another 2 more seconds, and I could finish the race at 60 miles per hour. However, my friend brings out his Honda Civic, right? Right. Starts in first gear, moves through second gear, then to third, and then to fourth, and to fifth gear, right? And by the time he reaches fifth gear, right, he's traveling at 75 miles per hour, but it takes him 10 seconds, let's say. I'm already finished with the race, and I'm at home. I parked my car in the garage, and I'm watching TV, and he's still racing right now, right? So even though he crosses the finish line, right, 10 seconds later, he still loses the race. So the answer is yes. You can lose a race even though you cross the finish line at higher speed. All right, any questions? All right. One more. Can an object, right? Can an object have zero position and non-zero speed? So what does that mean? Can an object have zero position and non-zero speed? Well, here's the road. Here's my zero position right here. Here's the positive position, negative position, right? And if I were to drive my this is my Escalade with double dubs, right? 22-inch wheels, right? And if I were to actually drive from here and passes through the zero position, right? Then I can actually have zero position with non-zero speed. Because if I'm driving here from this way at 60 miles per hour, I can go through the zero position at 60 miles per hour. So when I'm at zero position here, I have non-zero speed and position being zero. Or I could go the other way, right? I could go the other way and then have, right, car going this way where I could actually have, right, 65 miles per hour and then going through the zero position at 65 miles per hour, I can have zero position and non-zero speed at this location. So the answer is yes. Right? A car can, right? A car can travel, right, through zero position, right, at 60 miles per hour from the left, or 65 miles per hour from the right. And then it'll be at zero position with non-zero speed at origin. All right. Any questions? All right then. I'll stop the recording.